In addition to letter names, points of sound have scientific, mathematical names. At the left end of the piano, the first 4 points of sound have the following frequencies. Frequency, vibration per second, measured in hertz. .27.5 hertz, 29.1352 hertz, 30.8677 hertz, and 32.7032 hertz, with a difference of 1.6352 hertz, 1.7325 hertz, and 1.8355 hertz. At the right end of the piano, the last 4 points of sound have the following frequencies. (3,520) hertz, 3,729.31 hertz, 3,951.07 hertz, and finally 4,186.01 hertz, with a difference between these points of sound of 209.31 hertz, 221.76 hertz, and 234.94 hertz. How can this be? In 12-tone equal temperament, the distance between two adjacent points of sound is supposed to be the same. At the left, lower end of the piano, the first 2 tones are different by 1.6352 hertz. While at the right, high end, the last 2 tones are different by 234.94 hertz. How can these 2 spaces between points of sound be the same size? Every pair of adjacent points of sound has the same frequency ratio. We need some math to explain frequency ratio. You may have heard that mathematics and music theory are related. They are, certainly with the abstract concepts involved in each subject. But math and music theory are most related in 2 ways. 1, both are lacking in any useful imaginative, or interesting pedagogy. And 2, the most common result for students attempting to learn via traditional teaching methods is a lifelong hatred of each subject. That said, let's return to some math to explain frequency ratio. Remember, every pair of adjacent points of sound has the same frequency ratio. That frequency ratio is the 12th root of 2, drawn like this. 12th root of 2. The 12th root of 2 is an irrational number. 1.05946309436, etc., etc. It continues with no repeating decimal expansions and no known ending. Irrational numbers have non-repeating decimal expansions. Pi, 3.14159, etc., etc., is another example. The 12th root of 2 works this way with points of sound, frequencies. Remember the first 4 points of sound at the left end of the piano. Multiply 27.5 by the 12th root of 2, 1.05946309436, and you get the next frequency, 30.8677 hertz. Multiply 30.8677 by the 12th root of 2, and you get 32.7032 hertz. Continue this process 83 more times until you reach the last 2 adjacent points. $3,951.07 hertz times 12th root of 2, and you get the final point, 4,186.01 hertz. Or do the opposite. Divide 4,186.001 by the 12th root of 2 and get 3,951.07. So, the distance between any 2 adjacent points of sounds is the same. The 12th root of 2 used as a multiplier to increase the frequency, or a divisor to decrease the frequency. You could also determine the frequencies of the first 12 points of sound, then double each to get the next 12. In 12-tone equal temperament, frequencies double every 12 points of sound, every 12 tones.